Hi everyone, welcome to this video on Pythagoras' theorem. This is the first of three videos that I'm going to do just looking at how to use the idea of Pythagoras to find the missing side of a right-angled triangle. On that note, Pythagoras' theorem only works when the triangle is right-angled. If you're presented with a non-right-angled triangle, you might still be able to use Pythagoras, but you would need to create your own right-angled triangle. All the examples we're going to look at today are right-angled triangles. We are more concerned with what the theorem says and how to go about using that theorem. Okay. In short, what it says is if you take a right-angled triangle, maybe where this side is 3 units long and this one is 4 units long, and this one would be 5 units long, then it says if you make squares, so it's as much to do with squares as it is to do with triangles, on each of the sides, then the size of the biggest square is equal to the sum of the two smaller squares added together. And when I say size, I'm talking about their areas. Yeah, so what's the area of a square with side 3? Well, it would be 3 by 3. 3 times 3, so it would be 9. One that's 4 by 4 would have an area of 16, and one that's 5 by 5 would have an area of 25. And what you can see is that this square plus that square equals this one. 9 plus 16 gives you 25. And this is the case for all right-angled triangles. The sum of the two shorter sides squared equals the longest side squared. Okay, so that's the idea that we're building on. We are going to use a little formula. First thing we're going to do though is we need to know the name of the side that we're finding today. It's called the hypotenuse, and the hypotenuse can be found in the same position on every right-angled triangle, and that position is across from or opposite the right angle. Now on these diagrams here you can see the right angle denoted by these little squares. That's rather than writing 90 degrees in those spaces. Okay, so where is the hypotenuse? The hypotenuse is opposite the right angle, and I quite like doing these wee arrows on my diagram. It points to the hypotenuse. Again, if we do it on this one, points to the hypotenuse. And you can see that in both of these cases, the hypotenuse is the side that's missing, and that's the only type of example I'm going to cover in this video. The hypotenuse is always the longest side, and so when we're getting our answers for these, we expect the value that we get for this to be bigger than the two values that were already given. If these are shorter sides, this should be an answer that is longer than those, and that's a really quick check you can do to make sure you've got your solution correct. Okay, what we're going to do for all of these examples as well, we're going to use 3 letters. We're going to use the letters A, B, and C, and the hypotenuse will always be denoted by the letter C. Okay, so it will always be denoted by the letter C. So we're going to call the longest side C all the time for all the questions. And then the shorter sides, we're going to call them A and B in any order we want. So I'm going to call this one A and this one B, and over here, this one A, this one B, that kind of thing. Okay, so you're going to do that for all of your questions, and the longest side, the one that your arrow's pointing to, is going to be C. This allows us to use a little formula, and the formula looks like this. It says that C squared, so when I take C and square it, like you saw in the original diagram, it's equal to the square of A added to the square of B. And this is the formula we're going to use for all of these videos, and we're going to use it in 2 kind of different capacities across the 3 videos. Okay, but for today we're finding the hypotenuse. Okay, next thing we have to do is we're going to substitute in what we know about these triangles. C is just called C, so we're just going to leave that as C squared. A in this case is 5, so it's going to become 5 squared, and B is 12, so it's going to become 12 squared. And now we've got some squaring to do, so we're actually going to go ahead and square 5, which is 25. And we're going to square 12, which is 144. And it's mentioned in your slides, it's helpful if you try and learn your squares. I even know the squares up to 20, which I think is quite a good number to learn to in terms of trying to get some of these questions done a wee bit more quickly, maybe trying as much as you can without a calculator, just working on your number work. Okay, we're nearly there with this. We are then going to add these two values together, so we get 169, and we've got 2 steps left to go. I'm out of space, so I'm just going to come over here to finish this one off. C squared is equal to 169. We don't want c squared, we just want c, and c is equal to the square root of 169. We're talking about a length, so only the positive value of the square root, which means we get an answer of 13 centimeters. Okay, square root of 169 being 13. And those are the steps that you're going to be working through for all of these questions. Yeah, we're taking c squared equal to a squared plus b squared, square it out, add it together, and then square rooting to get your final answer. Okay, let's look at question B. I'm just going to leave the formula there because we're going to use the same one for all the questions. Okay, and here we go again. So we've got c. It's the thing that we are looking for, the unknown, so it's still just c. A is 8, so we've got 8 squared, and we're adding that on to b, which in this case is 4 squared. Now it doesn't matter which one you call a and b, you get the same solution even if you switch these round, so don't get too hung up on that when you're trying to label your triangle. The only one that you must get right is c, and it's across from the right angle. Okay, we're going to do our squaring this time, and we get 64 and 16, and that gets me that c squared is equal to 80. Okay, one more thing to point out, squaring isn't doubling, remember, so a lot of the time we might see 8 becoming 16 when we square it, yeah, so that would be doubling, not squaring. Squaring you multiply by itself, so 8 times 8, 64, 4 times 4, 16. Okay, I'm out of space again. I'll try and fit the next example all in one row so you can see exactly what it should look like. If c squared is equal to 80, then c is equal to the square root of 80. Now I know that 9 squared is 81, so I know this answer is really, really close to 9, but it's not exact. So I'm going to get my calculator here and just show you how to put this into your calculator. So we've got our square root button just here, so we're going to just push square root. I'm going to type in 80, we're going to push equals, and we get this big, long, irrational number. This number goes on forever, it never recurs. And it is 8.9442791, okay? I'm going to write down the first 3 decimal places, and then I'm going to round all my answers to 1 decimal place, okay? So C initially is going to be 8.944. I'm going to use 3 wee dots just to show that that does continue, and then I'm going to round my answer to 8.9, okay? And that's correct to 1 decimal place. Okay, forgot my units, should be centimeters as well in there. Okay, third and final example. Here we are here. I'm going to get this all in one line so you can see exactly what it looks like. First thing I've got to do, label my side. So remember, the only one you've got to get right is C. It's across from the right angle. So here's C over here. Doesn't matter which round we call them A and B. Call this one A this time and this one B. Okay, and I'm going to write down my formula. So the formula starts with c squared equal to a squared plus b squared. I'm going to substitute in. So c squared is equal to a is 9, so 9 squared, plus b, which is 5, 5 squared. I'm going to square these now. So c squared is equal to 9 squared, which is 81, plus 5 squared, which is 25. I'm going to add these together. C squared is equal to 106. Okay, and I want to know what C is. So I'm trying to undo this squaring process by doing the square root. Okay, again, that's not exact. It's quite close to 100, which I know is 10 squared, so it's a little bit bigger than 10. But here's what this looks like. So we are going to take the square root of 106. And we get this number that is just bigger than 10. So I think approximating first will let you know if you're getting something reasonable when you put it in your calculator. And we get 10 point, I'll do what I did last time, so 295, 3 dots to show that goes on. And then we are going to round this to 1 decimal place. So 10.3, I'll not forget my units this time, centimeters. And I'm just going to let somebody know I've done that to 1 decimal place. Okay, that's using Pythagoras' theorem to find the hypotenuse of a right-angled triangle.